we go to part 2. We were talking about what a like term is, and remember we're just talking about the variable parts. So in order to identify like terms, we're looking at just the variables. So for x and y and x, we're okay there. Order doesn't matter because it says the variables may appear in any order. These would be like terms. And as I was saying before, I would reorder this so that they do have the same order. Remember, these are all being multiplied. So when you're multiplying, it doesn't matter which order you're multiplying in. So I could call this yx, or I could call it xy. It'd be the same thing. That equals xy. They're the same thing. That's our commutative property there. Doesn't matter which order you multiply in. Okay? And once again, I know this may be confusing, but it is something we're going to spend a lot of time on. So don't worry. So these would be like terms, negative 5xy and yx. Unlike terms would be something like 2xy and negative x squared y. The only reason these are not like terms is because this one's squared. Okay? So if you see different terms that are squared or cubed or to the fourth power or anything like that, they have to look identical. The variables have to look identical. The order doesn't matter, but let's look at something like 2x to the fourth, y to the fifth, and negative 3x to the third, y. These are not like terms. Okay? These are not like terms because we have different variable associations. So x to the fourth, x to the third, they are not to the same power. Y to the fifth, and y, they are not to the same power. These are not like terms. These are not anything that we could combine, like I'm going to show us in a second. Okay? Just to show you one that could be a like term with this one, we could say negative y to the fifth, x to the fourth. This would be a like term because we have y to the fifth, x to the fourth, x to the fourth. These are a bit extreme. We're not going to get into quite this difficulty yet, but we will start learning from some of the more basic things. Alright. So it says here, we can combine or collect like terms by adding their coefficients. Okay? So they're taking the like terms that we had here, negative xy and yx, and they're going to combine those. So let's say we're adding those together. Negative 5xy plus yx, that's what's given. And they do what I said to do. They switched around the order here. xy. The coefficient here is 1. Remember, if you don't see a number, it's a 1. And now we have negative 5xy plus 1xy. And they just said change these around and turn that into a 1xy. And now all you do is add the coefficients. You add negative 5 plus positive 1, and you get negative 4. We've combined these like terms. I show you that here. Negative 5 plus 1 is negative 4. Negative 4xy. Okay? Let's try that with a couple. Alright. We want to simplify this expression, and I'm going to show you something that might help you out quite a bit. I like to go ahead and look and say, okay, is there anything that looks like, okay, we're looking at the variable x. Is there anything else that just has an x? And what we're going to do is we're going to underline this. Actually, let's box it. Okay, that's a positive 3x. Is there anything else that has just an x? And there is one other thing that just has an x. And I'm also going to circle or square the symbol in front of it. Now I know that's a negative x right there. And remember this, we don't see a number, so there's actually a 1 right there. What we're going to do is we're going to combine those two in a second. And we also have two constants out there. We have a positive 2 and a positive 3. Those are constants. We can combine those. So let's square those off. And what we're going to do is combine those. Okay? So first let's add our constants because we can add two digits together. We've done that for years. Positive 2 plus positive 3 gives us positive 5. Okay? Now let's add together our x terms, is what I would call those, x terms. 3x plus negative 1x. Or, we know we're going to get an x here. 3 plus negative 1 or 3 minus 1 gives us 2. So this is your solution. You've combined like terms and you've made things look much more simple. Okay? Eventually this will help us when we're solving for x. We're not solving for it here, we can't, because this equation is not set equal to anything, but we will be able to do that in the future. Alright? And lastly here, just to show what the perimeter of this rectangle would be, we can't solve for it. Oops, this would be, this side is 2x, which means this side is 2x, this side is 3, which means this side is 3. We know that perimeter of a rectangle or the perimeter of anything, we just add up all the sides. So it'll be 3 plus 3 plus 2x plus 2x. Alright, so we know we've got two constants we can add together. 3 plus 3 we'll get 6. And we also have positive 2x plus another positive 2x. So we basically have, we're going to get an x here, and we're also going to have 2 plus 2, we'll get 4. So we have 6. Or I'm going to reorder it, 4x plus 6. That's how we would represent the perimeter there. We do not know x, and we cannot solve for x, so we don't know what the actual perimeter is. Alright, like I said, this is a very new concept, and we're going to spend quite a bit of time on it, so don't worry if it's not coming together yet, but we will spend more time on it. Thank you.